So if you go back to the objectives table, one of the things that you need to, one of the objectives is to address all the additional considerations. And we saw this in the previous module, is that one of the things that you have to consider is a thing called deactivated code. And remember, this is executable object code, which is either not intended to be executed or used, or only executed in certain configurations. A would be part of, an example would be part of previously developed software. I mean, I'm using a previously developed software component, but I really don't need every single portion of that for my new product. That would be an example, deactivated code. Or you can actually have a piece of code that's, for example, not being executed since it is, it is in a particular configuration with a particular target computer. I may run the same code on multiple target computers, but for each target computer, only certain subparts are being utilized. Yeah. If you use deactivated code or make use of it, you must address this in your planning process. Also, you must not confuse this deactivated code with dead code. Dead code really means code that's in your program as a result of a design error. It cannot be executed. Yeah, maybe you have an if zero there for whatever reason. So if that's the case, that code is undesirable. You need to get rid of it. Now there's a whole chapter in the book, chapter 17, that talks about the ins and outs of deactivated code. I would recommend going through that chapter. In addition, there's user modifiable code, which is software intended to be modifiable by the aircraft operator without review by the certification authorities, every manufacturer, equipment vendor. Yeah. Of course, all these modifications must be within the original certification project constraints. Yeah. For example, this would be a single memory bit that you change to select between different pieces of equipment, for example. Or if you have one box and it's being used for multiple aircraft, there may be a software table of messages, for example, on the ICAS, the engine indication and alerting system. Yeah, so there is things like that. Well, also user modifiable code must be addressed in the planning process. And lots of this stuff is described in chapter 19 of the book. Okay, so the other thing that you really need to directly mention is the environments that you're planning to use. If you develop software, you need to say, what development environment am I going to use? Am I going to use a tool or something else to help me out developing the software component? Also, in this environment section also includes any possible language and compiler considerations. If you choose a particular language and a compiler to go with that language, are you going to make use of compiler optimization features? And if so, you need to make sure to indicate those. Now, of course, related to that is the test environment. What kind of tools and methods am I going to use to test the code? And of course, in the verification set modules, we're going to talk a lot more about, okay, what are these tests, how are these tests executed? But in the plans, you need to say, okay, what kind of methods am I going to use? What kind of tools am I using? Am I making use of an emulator or a simulator, or I'm going to use the actual target platform? These are all items that you need to make sure that you define. The other thing that we saw in the objectives list is that we identify development standards. For the requirements, for design and the code. In other words, you're going to go down the falling edge of the V. You're going to look at the requirements, design, more detailed requirements, and then the code that we derive from the design. Well, in these particular cases, for example, if you look at the requirement standards, they really talk about taking the system requirements, extracting all the software-related requirements, and then turning those into a set of high-level requirements that are software-specific. Also, the software requirement standards talk about how you're going to do that. How are you going to state your requirements? Are you going to do this by textual, or are you going to go with some kind of notation? These are things that you need to establish in your requirement standards. So you may want to establish this within your company by yourself, come up with your own standard, or you can use an external standard. It also typically includes the constraints that you have for using development tools. For example, if you use a requirements tool, like for example doors to make your high-level requirements, this must be addressed. This tool, the use of this tool must be addressed, and the limitation constraints of this tool must be included. Design standard, here you're really kind of going to say, okay, I'm starting out with a set of high-level requirements. I'm going to break these down into more detailed low-level requirements. And we've not talked about this yet, but the low-level requirement is really a requirement for which they can directly derive the source code. Well, to go from high to low level, I'm using software design standards, and you may talk about, okay, what kind of naming conventions am I going to use for these low-level requirements? And I'm going to make these textual, or am I going to come up with some kind of pseudocode? What am I going to do to implement these? So in your design standard, you're going to say, okay, how I'm going to take the high-level requirement and turn it into the low-level requirements. Yeah. May also include things like complexity restrictions. How many nested calls are you going to do? Are you going to exclude recursion and dynamic objects, like you would have an object-oriented program? Then finally, of course, you're going to take these low-level requirements and turn them into source code. So then you also need to use software coding standards, like for example the MISRA C coding standard, in which you're going to kind of identify what programming language am I going to use and how am I going to represent the code. Am I going to have a line restriction? How am I going to represent variables that are integers or doubles? And what are you going to do? There's a variety of different naming conventions of component programs, variables that exist in the literature that you can use. And it's very important for you to establish those as part of your planning procedures. Now, so if you write, if you use these standards, you need to conform to it. So if you write high-level requirements, you should conform them to the requirement standards. Your low-level requirements and your architecture, we'll talk about these three things in a little bit, should conform to your design standards, and the source code should conform to your coding standards. So in these cases, it's very important, these things are very important to your transition criteria. In your transition criteria, you can say, well, okay, the high-level requirements that I just generated, these textual things that say this software component shall calculate the standard deviation of 50 input variables. And what you need to establish are these requirements conforming my standards is one of the checks that you need to make when transitioning.